Hello, we are here today to talk about the digital transformation of operational excellence programs. As a quick procedural note, if you have questions during the presentation, please enter them into the Q&A on Zoom or into the comments on LinkedIn. I will get to them at the end of the webinar. The goal for today is to explore how to supercharge operational excellence programs with digital solutions. But first, we can ask, why is this even an issue? Do OpEx programs really need to be updated? And what's the benefit of doing so? One quick note is that manufacturing has really embraced technology over the past several decades. In fact, manufacturing has almost always embraced technology and automation. However, operational excellence teams have been resistant to automation and continue to use whiteboards and printed Excel spreadsheets. Just look at all the innovations that have come to manufacturing over the past 10 to 20 years with robots, augmented reality, lasers, and many things that seemed futuristic just a few years ago. It's really amazing to see all the advanced technology embedded into the manufacturing processes across industries. But when I walk shop floors, I still see whiteboards being used to manually track shop floor information. For these companies, somebody either must type the information into Excel or it is lost as soon as the whiteboard is erased. Or I will see SQDCIM boards where people are printing information from Excel and posting to the boards on a daily or weekly basis. Either way, you really end up with a shared folder full of these Excel spreadsheets. The whole process is very wasteful. There's excess motion, rework, defects, and more. At this point, these boards are due for some automation. This is a study from Bain & Company in 2019 that shows how much more gains can be achieved by combining digital solutions with lean programs when compared to just lean programs alone. There's really a big opportunity to be gained with Smart plus Lean. Next, let's cover what an Operational Excellence 4.0 program actually looks like. First, just a quick note on our definition of operational excellence here at Visual Decisions. I've seen a number of definitions for OpEx across different companies. Some use it synonymously with Lean or Lean Six Sigma. For other companies that have not adopted lean manufacturing, it's a separate but similar set of practices, but maybe without Lean's emphasis on pull or other elements. The framework shown here is what I will use if somebody asks me for my definition. I think it's a pretty common set of central tenets across most OpEx programs that I've run across. While digital transformation can certainly impact each and every single one of these different areas to a great extent, I'll be focusing on process excellence, quality, standard work, strategy deployment, and the high performance teams. There just isn't enough time in a 30-minute presentation to do it all justice. I have separated the transformation into two main components, the management system and the toolkit. The management system primarily addresses the strategy deployment and the high performance teams portions. And then I'll dive into the toolkit to show how we adapt these standard pieces of the Lean Six Sigma operational excellence toolkit for digital transformation. These tools will help with the process excellence, quality, and standardization pieces. So I've discussed the management operating system or SQDCIM system that we've developed for various customers in previous videos. That concept is based on the lean manufacturing policy deployment or Hoshin-Connery system. The objectives at any given level of the organization are driven by the measures at the level above. And this helps to create alignment throughout the organization. We took this process a couple of additional steps. First of all, we made the system live by connecting the measures directly to the sources of the data. Everyone in the organization can see where they stand against their measures at all times. And second, we incorporated the capture of root causes for misses versus target and corrective action tracking right there in the system. This creates a large number of benefits for the organization, including alignment, accountability, collaboration, and the reduction of manual work currently being done in tracking performance or spreadsheets. And this is a quick look at the implementation of that digital management operating system at one of our customers. The metrics are all real, but plant locations and names are all changed. As you can see, the system gives whoever's logged into the system a view of their metrics and how that fits within the overall organization's performance. When I first started Visual Decisions, I was working with a customer where I was putting together dashboards for their operations. In talking with the chief operating officer, I asked what he wanted his plant managers to be able to see on their dashboards. His response was that he wanted them to see everything they needed to know if they were winning or losing that day, but nothing more than that would distract their attention. There could be drill downs or other reports with additional details, but he wanted them to be laser focused on winning every hour, every shift, every day. The other question that he wanted answered for individuals is, what should I do next? And those two questions are at the heart of what we're trying to accomplish with the digital management operating system. If we can answer those questions for everyone in the organization at any point in time, we have driven real alignment throughout the organization. Another question that needs to be addressed is, who needs to change? With Industry 4.0, there's always a natural focus on the shop floor. Without question, operators, supervisors, and production managers are going to need to adapt and change and build some new skills. However, the support teams will also need to adapt. Manufacturing engineers will have an array of new tools at their disposal. They'll have to figure out how to take advantage of those in their daily work. The continuous improvement team will need to know how to use these new capabilities for root cause analysis and remove waste from the process. Quality will have a myriad of different ways to analyze and control variance. Even the maintenance and facilities teams will have new tools and responsibilities. The IT team will need to work much more closely with operations than they have in the past. And in fact, many companies, the line has started to blur for people between the operational technology and the information technology people. Finally, management has to embrace the change. They have to do more than just sign the checks. They have to know enough about these systems to know what the business is capable of after the implementations and how to lead the team there. There will also be enhanced visibility for them into the daily operations of the business, and they need to be able to know enough to take advantage of that. The concept of standard work for operators is very well known. The benefits are pretty obvious to everyone. However, the concept of standard work for leaders is not often discussed. The following are some examples of what a leader could have as standard work items on a daily or periodic basis. Reviewing performance trends, spot checking or signing off on various visual controls, lead weekly plant performance or improvement review meetings, reviewing process and product improvement work, verifying other leaders' standard work, verifying team leaders, supervisors on the floor, and Gemba walking each value stream, utilizing some of this data as they go. The daily accountability process is one of the biggest keys to driving success. It ties very closely into the standard work. The data coming from the shop floor should be reviewed at least daily with the operator. Not only does this ensure that the data going into the collection systems is complete and accurate, it also ensures that the supervisors and management are looking at the data to see what is happening on the shop floor. This leads to a common understanding of where the key issues are and is really the first step in solving the problems that exist. But utilizing data doesn't mean to sit behind a desk. It is still required to spend as much time as possible out on the shop floor, linking what the data is telling with actually observing the process. The key difference after digital transformation is the level of conversation that can happen during the walks. When the information about quality and efficiency performance is readily available at the click of a button, management can engage their employees in a much deeper problem solving as they walk the floor each day. Next, I will take a look at the OpEx toolkit and how the tools can be updated through digital transformation. Since this presentation is only 30 minutes long, I'm going to be going through some of the key pieces of the toolkit in detail. Then I'll do a lightning round of additional impacts. So how does Industry 4.0 and digital transformation help standard work? We will get into more details as we go through the presentation, but one central idea is that the right information is delivered to the right place at the right time in the right form. That alone can help many different people doing different jobs. Another key area is augmenting people in the organization with new capabilities. As standard work is being created, those standards should be as optimal as possible. This group of ideas centers around how to help people in their different roles expand their capabilities as much as possible. Providing tools to enable those new behaviors also helps to standardize the approach within the organization. Because these solutions are going to provide set workflows, it naturally encourages people to use a common approach to the tasks the solutions are meant to address. One more area where Industry 4.0 can help is by detecting deviations and elevating. When using solutions to monitor the process in detail on a 24/7 basis, the system can identify when people are performing a task in non-standard ways. Conversely, how does standard work help Industry 4.0 solutions provide value? The analogy I use a lot to explain this is a Fitbit. The sensors work great and accurately track steps and other activities. The software works well and provides detailed information on those activities in a very user-friendly way. However, just wearing the Fitbit and looking at the charts and graphs does not cause weight loss. To lose weight, you still have to change your exercise and diet to really get that weight loss. So the behaviors have to change. The Fitbit can still provide a lot of value in helping to inform and shape those behaviors, but people have to do something differently tomorrow than they do today to get the benefit of the technology. And it's the same thing on the factory floor. These systems can be implemented perfectly from a technology perspective. Sensors can be added to the machines and data can be extracted from the PLCs. That information can be presented to users in an ideal fashion. Machine learning systems can be trained with that data to accurately predict when machines will go down or quality problems might arise. But if people still do the work in the same way that they did yesterday, nothing has changed and no value will be created. And that's where the standard work comes in. By utilizing standard work as a tool to help enforce new practices, the implementations or transformations can be much more successful. This can help drive adoption of the new systems by the workforce. One more key point. Sometimes manual data entry is required to supplement the automatic data collection. A typical example here is downtime reasons for machine stops. In many cases, one of the top reasons for stoppages reported by a PLC will be e-stop, which does not provide much value for downtime analysis. In these cases, the operators will often be counted on to provide context for those downtime events where sensors cannot determine the reason for the stop. Sometimes this could be issues with the machine, but it's often more of a process disruption. Stops a sensor could never detect. If these events are fed into a machine learning application without any sort of context, it can make the results from the algorithm significantly less accurate. Creating standard work around the operator input will help to make this data much more accurate. Creating leader standard work around the validation and use of this data will do even more for the accuracy of the input and the value of this information. This is just a quick example of how standard work can be delivered to the operator on the shop floor. Many shop floor issues happen because workers either don't know the standard work or they don't follow the procedures. Digital solutions can display the work instructions in context at the work center to help workers follow the standard work much more easily. They can also be used to monitor for deviations from that standard work to help reinforce the training on the shop floor. Performance can also be significantly improved by providing in-context, hands-free visual instructions. When operators can easily see the instructions in the context of their work, it not only reduces error rates, but also facilitates a greater variety of builds with less training required. Just a quick note on augmented reality and standard work. I don't think I've ever seen a crowd gather on a shop floor like the ones that almost always occur when augmented reality solutions are first demonstrated. Not only are these solutions fantastic for training and getting adherence to the standard work, but they're fantastic for bringing an energy and element of excitement to the shop floor. I can't think of any other technology that has such an immediate boost to employee engagement. In addition, it really is the ideal way to portray standard work right in the context of the operation, particularly when hands-free glasses are used. A very common way of looking at manufacturing performance is with KPIs or key performance indicators. Went through a whole presentation on this yesterday, but these are often categorized into safety, quality, delivery costs, inventory, manpower, and environmental. As I mentioned yesterday, for a lot of companies, these are tracked in a very manual fashion and displayed on boards with people either coloring in the sheets themselves or printing them off from Excel on a daily, weekly basis and posting them up. And they're great because they're color coded and you can immediately see if the status is green or red for any metric. And that's wonderful. It's very visual. It's very easy to see where the problems are. But again, this can be done in a much more automated fashion with a lot less waste in the process. In the photo, I would argue that we're seeing a living example there of the eighth waste, of underutilization of human potential. I'm sure he could be doing something more valuable with his time than putting printed sheets into a magnetic holder every single day. That waste is one of the key problems with manual controls. For people to walk to the boards to enter information or read the information requires wasted movement. Writing the information on a whiteboard and then later capturing the information in Excel requires rework. As mentioned, it's a waste of time when this could be done automatically. The poor guy in the photo is an engineering manager. He could be solving problems in the plant, but instead he's printing out forms, carrying them over to the board and swapping out an old sheet with a new sheet inside the plastic holder. Another issue is that you get errors. Missing data can be a huge issue, as can transcription errors when somebody's transferring information to the boards from the source or from the boards to Excel. As an example here, I had a customer that was using a pasteboard to track production and downtime. Then they entered that information from the pasteboard into an Access database at the end of every shift. As a pilot, we connected an IIoT system, Industrial Internet of Things system, to some of the equipment in the plant to automatically capture the downtime events. We found that the boards and the Microsoft Access system that the information was being put into, that was capturing less than 10% of the downtime events. Most of the stops in the equipment were short stops, but they added up over time. The current approach was capturing less than 20% of the total downtime as well. Everybody meant well, but when the machine only stopped for 60 or 90 seconds for a jam, nobody bothered to write that kind of event down. So when they went to improve the performance through Kaizen events, they were using information that was woefully incomplete. They didn't even know what the big problems were, let alone the key root causes of that performance. And that highlights another problem, keeping up with a fast-paced environment. When it comes to capturing these minor stops, high-paced production counts, or any other rapidly changing information, manual methods just can't keep up. That's how you end up with less than 10% of events being captured. Then there are additional limitations. Information captured on a whiteboard is only viewable from right there in front of the whiteboard. Sharing information with other groups such as engineering, maintenance, purchasing, quality, or others is impossible unless they're standing right there too. In order to save or persist the data, it has to be entered into a system anyway. I've worked with customers that had major product recalls that had big gaps in their available information about what happened on the shop floor when those parts were being produced, because the information went onto a whiteboard but got erased at the end of that shift. Finally, there's only so much detail that fits on a whiteboard. A system can capture so much more context of what was happening at a machine or a process that just isn't otherwise possible. Next, I'll talk about how to digitize maintenance and the total productive maintenance process. One of the pillars of TPM is to have the operator take as much ownership of maintaining the machine as possible. It's sort of like doing your own basic maintenance on your car. It will be more efficient and probably done with more care and attention since you own the car. But a lot of people don't change their own oil or even their own wiper fluid. Other than being too busy, the biggest hurdles are some combination of not knowing how, not having the equipment, or not having the consumable, whether it's oil, fluids, whatever. It's the same thing for operators and their machines. They are measured on production, so they don't have the time. The equipment and the consumables aren't at the machine. They don't have instructions of what should be done when. They're unsure when to perform the tasks. Many of these issues can be addressed through digital transformation. The system will know how many pieces have been made since the previous activities, so the operator doesn't have to track that. The system can provide a list of, at any time, of what activities have to be performed and step-by-step instructions on how to do it. Now I just need to get all those tools set up in my garage at home. PM, preventive maintenance, has been a staple of increasing machine reliability and OEE for decades. For such a well-established process, what can digital transformation do to improve it? A lot. Many PM tasks are actually reactive in nature. They get added when a machine fails in a particular way. Task frequency is often an educated guess without a lot of validation done to optimize the timing. Task efficacy is usually not studied to ensure it's preventing what it was supposed to prevent, or whether it's actually needed in the first place. Using digital transformation to collect data can help address all of those issues listed above, but it has to be done with forethought and intention. We utilize a process and visual decisions to list out each PM activity and identify the following data elements from the machine for each task. The frequency of the failure mode the PM task is supposed to be addressing, sensor data process variables that we can utilize to contextualize and analyze the different issues that come up with the machine. And using the data in this way, it can help keep the machines running effectively while minimizing those PM costs. From a condition-based maintenance perspective, the impacts are pretty straightforward. Everything discussed with PM still applies, but now we're also monitoring those tags and process variables and setting tolerances on when we need to take action. And this is where some of the real power of the digital transformation comes in, is that ability to collect, contextualize, and analyze these different data streams. And then you can set the appropriate boundaries on those and notify people when that condition-based maintenance needs to occur. And finally, we can take that to another step and look at predictive maintenance. Basically, that's doing the same thing with condition-based maintenance, where you're pulling in those individual data elements, the tags, the process variables, the input variables, but now you're running those through a machine learning algorithm to be able to predict when failures are going to occur. And that helps you run the machine for as long as you possibly can before performing those maintenance tasks. I won't go into the details here, but these are the steps involved in reactive maintenance. Digital transformation can speed this process through augmented intelligence, improved communication and integration, remote support capabilities, and much more. There are quite a few possible structures to a Kaizen process. I've worked with many customers and I've seen different takes on what the steps in the process are. At its core, though, there's a lot more in common across the variations. The process I'll use here is just a very typical 6-step process: identify the problems, analyze, create solutions, test, measure, and then standardize. And IoT solutions and other technologies can help with all of these different steps. In terms of detecting problems, I think we've covered that elsewhere, but these solutions can track the data streams and be able to point you to where the problems are occurring and how big those problems are. You can augment with machine learning to understand why the problems are occurring, and we'll get into more into root cause analysis on the next slide. We can expand the solution space with additional capabilities made possible by Industry 4.0. Just as a quick example, we can implement a closed loop control system that adjusts based on environmental conditions. We can use technology such as simulation with digital twin or augmented and virtual reality to test the solutions. And that's particularly valuable when a major capital investment would be required to address a root cause. And then similarly to before, we can measure and analyze the results. And I've talked a lot about utilizing standard work to instill new disciplines. There are many frameworks for performing root cause analysis. In other webinars, I've gone through the details of each one of these different methods. Today, I'll give more of an overview of how each can be impacted, as well as drilling deeper into a few of the methods discussed here. So 5 Ws and an H, while that's discussed earlier in terms of clarifying and describing a problem, the method can sometimes be sufficient to get to the root causes of performance. Graphical evaluation, as a founder of a company called Visual Decisions, I'm big fans of this type of analysis, but smart manufacturing systems are fantastic for this type of analysis because they're so data rich. Most of the information that you'd like to know about in the process can be graphed, charted, shared for analysis. And then FMEAs, you can create an evergreen FMEA that I'll talk about in a while. This is the most common type of root cause analysis done in lean manufacturing environments, 5 analysis. The biggest trap I've encountered with this method is that people only ask why once at each level. And so you end up with something that looks more like line than a tree. And the other key problem that I've seen is that it's usually not done with data. It's usually done by people gathering into a conference room and asking people to go through the process anecdotally. 5 analysis can be greatly facilitated by having the data at each one of these levels. And in addition to the traditional brainstorming, the team can investigate the data to see where that shows as each question is asked. Next, we'll look at the Fishbone or Ishikawa diagram. This process is usually done in a highly manual fashion that is completely disconnected from the process. Another weakness is that while the diagram gives an idea of contributing causes, it does not show how much those causes contribute to the problem. When data collection is performed, it's usually done manually after the initial analysis has been completed. One way it is done is to give the operators tick sheets to note how often a failure on each one of those branches occurs. The other way is to have someone go out and watch the process and record that information so that the operator can continue their work. One problem with collecting the data by watching the process is the Hawthorne effect. People behave differently when they're being watched. Think of how drivers slow down when there's a policeman on the side of the road. This leads to the problem of bias in the data. The data that gets collected does not accurately reflect how the process normally operates. With Industry 4.0, we collect data at all times. This allows us to create a Pareto diagram of how much each of the causes is contributing to the issue. Then we're able to begin the Kaizen event with a very strong data set on all of the different causes contributing to the problem. and what's the most important to address first. Finally, I close out this section with a brief discussion of the gold standard of data-based root cause analysis. Some forms of statistical analysis that apply here are analysis of variance or ANOVAs, design of experiments or DOEs, linear and multiple regression, t-tests, chi-square tests. All of these methods are at the heart of Six Sigma analysis. Obviously, these methods are also very heavily dependent on data. The more data, the better. The richer and more contextualized that data can be, the better these methods will work. A lot can be gained through digital transformation of SMED or setup reduction. Augmented reality systems can be used easily to capture the current practices and settings for analysis. Once the process is complete, they can also be used to document the process for training purposes. Spatial computing, or RFID to some extent, can be used to do the spaghetti mapping of the current process. This is a motion study that is normally done only once or on the theoretical way that this process currently happens. Spatial computing allows for capture of movements during each and every setup to show how things really happen. IoT systems can capture a lot of additional information about the process, timings, machine settings, and all of the contextual information about the setups. This information can be used for analysis to understand what factors really drive variation in the setup process, as well as understanding what settings drive the best performance of the process itself. Similarly, each of these systems can help keep setup short and consistent after the event. They're primarily useful for training new workers to the process, identification of variance or deviations from that new set of procedures, providing visibility for when advanced kitting should begin, and improving planning and scheduling to minimize changeover times based on setup profiles. Now for the lightning round. Value stream mapping is usually done over the course of days or even weeks, while alternately locked in a conference room and out on the floor collecting data. Then the result gets hung up on a wall or stuffed in a drawer. Digital transformation in this process can really help automate to a great extent the data collection and the information already being collected through shop floor systems. This makes the process more comprehensive, more precise, more accurate, reflects the true process instead of being incomplete or biased, shows all of the ways the system performs instead of just the way it's supposed to perform, shows the distribution of times and events instead of just showing a single average or estimated time. And it can automatically update with the process. So instead of the VSM being stuck in a drawer or just hung up on a wall collecting dust, the VSM can become a living document that's used as part of the daily management process. Most people will acknowledge the value of performing an FMEA, or failure mode and effect analysis. The tool's been around since the 50s and has been used to great extent for both products and processes. Performing one has generally involved locking a cross-functional team into a conference room for at least several days while they brainstorm and develop the result. It inevitably generates tremendous insights into the process. But then comes the biggest issue. The results of these studies become stale very quickly. The results typically get printed on huge sheets of paper and hung on a wall or put in a drawer. As the process evolves, nobody goes back to update the FMEA. As downtimes and quality issues happen, nobody goes back to update the probability or severity of the different failure modes. In fact, I've yet to visit a single company that uses the failure modes from their FMEA as the reason codes for their downtime or quality tracking. And that disconnect just doesn't have to exist. With these systems, we can collect data from the process that allows us to both identify new failure modes as well as automatically keep the FMEA live and instantly accessible. And again, that can become part of the daily process to manage improving the process. These solutions can also be used to error-proof the process itself. Vision picking is one great example of how this can be done. As shown here, the bins with the parts needed for the current build can be highlighted. And this is just one way to error-proof the process using these solutions. There are a lot of others. This is just the best looking. All right, some closing thoughts, since I'm running over here. The biggest objection I get to digital transformation of operation excellence or lean programs is that we lose the fingerprints on the process, as was said by David Mann in his excellent book, Creating a Lean Culture. And I understand the objection, I just don't agree with it. The key is how these changes are implemented and the standard work and the culture that are built up around the transformation. When implemented correctly with a focus on transforming not just digitally, but culturally as well, there's a real possibility to get greater involvement, more lasting ownership, broader and deeper understanding, more possibilities for improvement, greater investment in the change. Reach out to me if you're interested in learning more about how to drive these things. All right, that's it for today's webinar. In the coming weeks, we'll be covering a number of great topics on our webinar Wednesdays. Be sure to go to the Visual Decisions website to register for them today. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve continuous improvement since 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Thank you for joining us today. If you have questions or would like to talk about how to apply these concepts within your company, please reach out to me. You can give me a call, send me an email, or go to the link on the page to set up a meeting directly. Thank you, and I will see you next week.